Hey there, this is the last type of problem that we're going to be working with. I didn't really know what to call it, but what we're essentially doing in this particular type of question is we are trying to figure out how dimensions of a rectangle changed when we know what the change in the area is. So let's take a look at an example, and maybe it'll make a little bit more sense that way. So we've got a friend, Mario, here, who wrote an equation that basically says that the area of a new rectangle, when it got changed, is 84 square feet greater than the area of the original triangle. And we want to know, how did the triangle change? So we're going to kind of let r here, little r, represent the original the area of the original rectangle. Sorry that I'm hesitating there. And we're going to let big R here represent the area of the new rectangle after it's been changed. And we're going to let X represent the width of the original rectangle. So, I don't know if you noticed this as I was reading it, but this number 84 here, there it is, 84, also happens to be right here. So if the area of the changed rectangle is 84 greater than the area of the original rectangle, then this side right here must be the original rectangle. And I'm sorry if I say triangle, I always mean rectangle in this recording. So that side, the left-hand side, represents the original rectangle plus the change in the area. So it's the area of the original rectangle plus the change. So that means that this little r is really x squared plus 7x. Which means that the right-hand side is the area of the new rectangle. So we're going to say that that is x squared plus 13x plus 30. Now, one of the things that we do with quadratics all the time is we like to factor them, because we'd like to see what the pieces are that make this up. So let's start with the original rectangle. And that area was x squared plus 7x. Well, these two terms have a common factor of x. So let's factor that out, and we get we will get x times x plus 7. And that's about as far as we can factor it. Then, if we look at the new rectangle, we have x squared plus 13x plus 30. And that factors out really, really nicely to x plus 3 times x plus 7. Sorry, x plus 10. Because 7 times 3 doesn't make 30. There we go. So now let's compare these two pairs of factors. This looks like, if we compare x, let me see if I can highlight these right. Looks like this, that's horrible. That x compared to this x plus 3, well, there's just a difference of 3. And then if we look at this x plus 7 compared to this x plus 10, well, looks like we just added 3. So we added 3 to the length and the width. That's how the rectangle changed. We added 3 to both dimensions, the length and the width. Now, we could try this out and see if that really works, but one thing is we need to know what x is. We need to know what the width of the original rectangle was. So we don't need to do this to answer the question. We've already answered the question. The answer to the question is add 3 feet to both dimensions. But if we just want to verify that, we have to figure out what this x is. And the way we're going to do that is we're going to take this equation that Mario wrote, and we're going to solve it. Now it looks weird because we've got a quadratic on both sides, but it's not going to be nearly as bad as we think it is, because if we really look at this, x squared plus 7x plus 84 has to equal x squared plus 13x plus 84. Nope, sorry, plus 30. Okay. And now we just want to get all of our terms over to one side. Or maybe have all our x's on one side and all of our numbers on the other side. Because if we subtract x squared from both sides, these guys go away. Makes it so much nicer. So let's subtract 7x from both sides. Then we would have 84 equals 6x plus 30. And subtract 30 from both sides. Then we get 54 equals 6x. And for that to be true, x has to be 9. So, if x is 9, then we have an original rectangle. Let me go back to my green here. Our original rectangle is a 9 by, well, 9 plus 7 is 16. So what is 9 times 16? Not sure. 9 times 16. 144. Cool. I like that number. So, that's the original triangle. Now let's see what's going on if we add 3 to both dimensions. So if I add 3 here, and I add 3 here, then this becomes 19, because 16 plus 3 is 19, and 9 plus 3 is 12. So now we have a 12 by 19 rectangle. And what's 12 times 19 to get the area? 12 times 19 is 288. No, 228. Yep, 228. Good. I wonder if 228, I should say it this way, I wonder if 144 plus 84 equals 228. Let's find out. 4 plus 4 is 8. 8 plus 4 is 12. Carry the 1, and we get 2. So it is. So we do have a correct answer that in order to make this happen, we need to add 3 feet to both dimensions. So this last part that I did with the pink and the 2 rectangles, you don't need to do that to answer the question, but it's a good way to check your answer. So even though this question seems a little bit complicated, it's really not all that bad. As long as we can see, I guess, this connection between these two things here. This right here, I think, has been the clue that helps us out. So I hope this works for you. And if you have any questions, of course, be in touch with me. I'm happy to help you out as much as I can.